Okay, task 2, hybrid ensembles. Okay, so here in this task, let me clear outputs. So here in this task, you were asked to build variants ensemble variants. So each of this ensemble will build using different type of models. So when we mean the different architectures of classifiers. So here we will provide CNN models and SVM models. So in order to config for different type of models, you can do either configure each type in an individual JSON file. So each file will looks like this one, model-mnist. Okay, let's see. So SVM models, when I was uploading it, because some of them is too large, so I wasn't successfully uploaded to the GitHub, but I'm working on it. Okay, so if you wanted to configure the model informations for each type of models in different JSON files, you will do something like this. So this model-mnist JSON, this file is the configurations for CNN models. So you can see here, architecture is CNN. So you will need a different JSON file for SVM in this case. So you need to make some modifications accordingly. But you can also configure the informations for all type of models in the same file. So as I did in this demo, so I config the informations for CNN models and for SVM models in this hybrid mnist. Okay. So here is the sample for configuration. So the Python tutorial, you can find it in this file, evaluate model. And then the demo we are using, in this demo, we are using this function, evaluate hybrid. So this function will require the configurations for transformations, for models, for data. And then the process will be very similar to what we did in task 1. So first we will load the models we wanted to evaluate. So basically the baseline model, PGD adversarial trained model, and then the undefended model. So here the undefended model here is actually because this the AEs I uploaded to this repo was generated based on this CNN undefended model. So the undefended model will refer to this one specifically in this demo. So we load the undefended model, and we will load all the candidate weak defenses since we have two type of models, we will load each type of the model into an individual pool. So that will make it easier for the weak defense selection. Okay, you will know what I mean in a couple of seconds. Okay, so in this demo, we have two type of weak defenses, the CNN models and SVM models. So we will load the CNN model into this CNN pool. And when we are loading the CNN models, we will pass the CNN configurations to the load pool function. So we get the CNN configurations through this key, by this key, and then we will get the SVM configurations and then load the SVM models into this pool. And in this demo, I will use very tiny pool as the example. So consists of 3 weak defenses. So it's the same here. Okay, so your major work for this in this task is to come up some strategy or some idea or some approach you can use. Yeah, anything you can think of to select the weak defenses for your hybrid ensemble. So I give you an example, very naive example here. So here I will try to build n variants. Okay, I will try to build n hybrid variants. That is n hybrid ensembles. So what I did is first I will fix the number of the total weak defenses I wanted to use to build hybrid ensemble. For example, 50 weak defenses, and then I will start from a simple one with 50 CNN models and 0 SVM models. So this is my hybrid ensemble 1. And then how will I get my second ensemble from this one? I will replace part of the CNN models with SVM models. So for example, I will replace 5 CNN models with 5 SVM models. Then I will get my hybrid ensemble 2. And then replace 5 more. I will build my hybrid ensemble 3 with 40 CNN models and 10 SVM models, and so on. I will get my hybrid ensemble N. Okay, this may not maybe this doesn't make much sense or something like that. You can come up better idea. We expect better ideas in this selection, this in the WD selection here, weak defenses selection. Yeah, so you can come up your own idea, not necessarily using this one. And then so when you select your CNN candidates and you selected your SVN candidates, you can build your hybrid ensemble like this. So in this example, I will build an ensemble using 3 CNN models and 3 SVM models. So first, I will add the selected CNN models to this list, to the list of weak defenses, and then I will add the selected SVM models to this weak defenses list, and then I will build my hybrid ensemble using the weak defenses that using the weak defenses I just selected, and then I will use adversarial probability as my strategy, as the strategy of this ensemble. Then we get then we have our ensemble model here. Then the next we will perform the evaluation. So this part was prepares for the error rate computation, because we need to get the samples that were correctly predicted by the ensemble, right? By the ensemble undefended model. Sorry, undefended model. Yeah. So these blocks were preparing for the error rate computation. So we load the benign samples, we load the true labels, and collect the list of the corrections. And now we can start the evaluation. We load the AEs. We then perform the evaluation using this undefended model, and we evaluate our ensemble on the AEs. Then we evaluate the baseline model on the AEs here. So if you have multiple ensemble variations here, you can use the for loop for this part. Okay, so and if you are doing that in a for loop, you might want to make this key changeable. So for example, plus some variable. For example, ensemble I, ensemble plus I, something like that, and then that I will change in each iteration. So you can distinguish your hybrid ensembles. Otherwise, you only check the last one, the last ensemble you built, if you do this in a loop. Okay, let's run this part. Then the functions is ready, and we prepare the configurations and then call the function to evaluate our hybrid ensemble. So you can see we load the CNN models, we load the SVM models, then we evaluate the AEs on using this undefended model, and we evaluate our hybrid ensemble on this AE. It will take a while. Okay, so evaluate the baseline model on these AEs, and then we will get the results like this. So the AEs generated using FGSM with epsilon equals 0.3. So around 88% of the AEs can successfully fool the undefended model. So that is the error rate of this undefended model on this AEs is around 88%. So when we evaluate these AEs using when we evaluate our hybrid model on these AEs, we can drop the error rate from 88% to around 40%. And then when we evaluate using the PGD adversarial trained model, the error rate will decrease from 88% to 21%. So I think that's pretty much it is for the hybrid ensembles. Or maybe one more thing. Okay, so for the SVM models, we have a wrapper so that the SVM models we are using was the scikit-learned models. So sklearn models. So yeah, let me show you. Oh, it's not here. Okay, anyway, and that SVM models was stored in this pico format in the form. Yeah, so you need to use this package to load the SVM models, and this is the wrapper to wrap the sklearn models as the weak defenses in the ATHENA. Okay, I think that's it.